way you can meet my
Crazy was by doing something crazy yourself. Thank you. I love you. I knew it the minute I met you. I'm sorry it took so long for me to catch up. I just got stuck. Pat. I wrote that a week ago.
You wrote that a week ago?
Yes, I did.
You let me lie to you for a week?
I was trying to be romantic.
You love me?
Yeah, I do. Oh, man. Oh, man. I love that movie. Oh, Silver Linings Playbook. If you've never seen it, oh, man. It makes me teary-eyed just watching it, man. Oh, if you've never seen the movie, go see that immediately. Okay, I know I just spoiled the ending for you, but that's not the point. It's got a lot of substance to it, okay? Well, you caught me at a wrong time. You know, this weird way to start off a video, but love's complicated, man. And so is math, okay? And love is really math if you break it down. It's about communication. It's about solving problems. It's about relationships, really. And so we're going to talk about how we can use love, the idea of love, to help us with our math, and vice versa. So, starting today, we're going to look at something called mappings. We're going to look at relationships between things, determine whether or not something's a function, and finally, most importantly, we're going to use math to come up with homecoming groups. Whether you're going with a group of friends or a significant other, homecoming is a time of love, and what better time to work through love than now with your math lesson. So, without further ado, let's come up with some mappings for homecoming. Here's some type of mappings. First of all, let's talk about what a mapping is. That might be easy to get us going, right? That might help us a lot. So a mapping is really just a set of inputs. It could be anything. It could be numbers. It could be objects. Just some kind of thing, inputs, and how they relate to a set of outputs in this case. In this case, our inputs are a group of guys, and our outputs is a group of girls. And they're all friends, and so they go with each other in different ways. So there are 4 ways that they are going to go to homecoming, and they're trying to figure out which one to go with. So this first one seems pretty straightforward. They're all just going to go 1 to 1, right? Each Jeff's going to go with Tamala, Stanley, Sarah, Malik, Macy, TJ, Gwen. In fact, this mapping is, how the name suggests, called 1 to 1. This is a 1 to 1 mapping. Every input has exactly 1 output. Our domain, each domain has 1 unique set, 1 unique object for its range. Which brings us to our definitions real quick before we continue on with the mappings. Domain is just possible set of inputs. I said my inputs was just a group of guys. But I could keep adding to my domain. There's lots of different guys that would go to a school. Same thing with the output. There's a lot of different girls that would go to a school. So a range is also our possible set of outputs. Let's see how the domain and range changes and how that might look with different mappings. So now Chad is coming into our group of guys. Chad is a player, first and foremost. So, for Chad, he was able to somehow take Macy and Gwen to homecoming. TJ went with Sarah, Malik went with Tamala, and poor Jeff and Stanley are dateless, so they decide to go with each other and to run amok at homecoming and have an awesome time, which is great, okay? Still going to work out for Jeff and Stanley, but this type of mapping is called, because Chad now has 2, 1 to many. 1 Chad is getting many outputs. Chad, that's going to come to bite you in the butt later on, man. But we will see. We shall see how that will, okay? Moving on to the third one, the third mapping. I'm going to block domain and range for you, okay? So again, we have our domain. This time for our range, our outputs, we added on to our range. We now have Olivia into the mix. And now this time, Olivia, she's going to be a player this time. She's going to take both Jeff and Stanley this time because they didn't get to go on dates with the other group. So Jeff and Stanley will go with Olivia, Malik will go with Tamala, and TJ will go with Sarah. And now Macy and Gwen, kind of in a pickle like they were with Jeff and Stanley, they're going to go with each other. If this was one to many, this one is many to one. We're taking many, Jeff and Stanley, to Olivia. So this is many to one. And you're probably seeing a pattern. You're seeing how this is going. For this last group, they're all friends. They're just like, you know what? Who cares about going who with who? It got complicated. Let's just go with each other. Jeff is going to go with Macy and Gwen. Stanley going to go with Tamala and Sarah. Malik is going to go with Tamala. Malik is going to go with Olivia. TJ is going to go with Macy. TJ is going to go with Olivia. And Chad is going by himself because he is a player. And there's no time for that in this friend group. And so this is many to many. Jeff has multiple dates. Stanley has multiple dates. Malik has multiple dates. TJ has multiple dates. Many to many. Now, these are all mappings. These are all relationships between inputs and outputs. A function is a special type of relationship. It's a relationship in which each input has only one unique output. So for example, let's look at these and let's determine which one's a function. Which of these are functions? If we look at this first one, each input, Jeff, has one output, Tamala. Stanley, Sarah, Malik, Macy, TJ, Gwen. Each input is getting one output. So actually, a one-to-one is an example of a function. Okay. Let's go on to the second one. We have one-to-many. Again, we have Malik going with Tamala, TJ with Sarah, Chad with Macy, and Gwen. Chad, the player of the group, is getting one input, and he is getting two outputs out of it. So based off our definition for a function, a relationship in which each input has only one unique output, he's not getting one unique output, he's getting two. So this is not a function. This is not a function right here. Okay. What about this one? Okay, many to one. We have Jeff, who is getting to go with Gwen. Or, I apologize. Jeff is being able to go with Olivia. And that's it, actually. Stanley is also being able to go with Olivia. Olivia has two inputs that are linked to that one output. Based off our definition, a relationship in which each input has only one unique output. In this case, this is a function as well. And then many to many. Just by the definition, we know right off the bat this is not a function. Now, these two are the only mappings that are functions because, well, they each have one output out of this, right? One output. That's kind of the key right there. Anytime they have one output right there, that's how you could tell this is a function, okay? So let's see it in a more clear example. If I give you a random mapping like this, no context at all, and I'm saying here's your inputs, here's your outputs, we can determine the mapping type. We can also determine if it's a function or not, okay? Looking at this, all right, we have this input that's being linked to two different outputs. So right off the bat, just by telling us what mapping it is, we know that it is, just by looking at our mappings, let's kind of check it out, we're getting one that's getting to many, right? It's kind of like this is the Chad of the group. Oh, Chad. Chad is messing things up, so this is a one-to-many mapping. One input's getting many outputs. Is it a function? As a result, it is not a function. Okay, so you'll have homework problems that look just like this, Very arbitrary, but again, I want you to get used to using the mappings and kind of being able to identify them. So this is all well and good, but let's see it from a graphical standpoint. Now, with the graphs, I was able to link up each of these functions, or I apologize, each of these relationships with each of these graphs right here. So for example, here's a one-to-one, okay? Our domain for these is going to be x values, right? And our range are going to be the possible y values get out of it. Okay? So our domain in this case, each input is getting exactly one unique output every single time. This is one-to-one. Okay? It's just one-to-one. I can link each x value to each y value. Moving on to the second one, we have many-to-one, right? So I have an x value, and by the way, this is a function y equals x cubed minus x. If I throw in -1 for my x value, I'm going to get a y value of 0, as you can see. But if I throw in an x value of 0, I'm still going to get a y value of 0. And same thing, x value of 1 gives me a y value of 0. So many of these are getting me still just one output value, but I'm getting many inputs that are doing that, hence why it's many-to-one. Okay. Again, let's see how this looks for the other two cases. For C, we have one-to-many. Okay, we have this this exponential graph that's kind of branching out in two directions because of this plus or minus. All right, this is one-to-many. Again, same thing, same way of thinking. See if your input. So let's call this our input. This one input, so that's about, let's just say it's x equals -1, is giving me two y values. Okay, one input is giving me many y values. So this is one-to-many. And finally, many-to-many, where I could plug in, again, an x value, and I will get a y value here and a y value here. And it kind of does this, right? Both of these kind of do this. And these ones are not my functions, right? These ones are my functions. So this brings me to a nice little test called the vertical line test. This is, if I draw a vertical line on my graph, and it hits two unique y values, the graph is not a function. You don't even have to draw it. You can just take a vertical line like your pencil or pen and just put it on your graph. As you can see, I'm hitting here and here. This is not a function. Same thing over here, and I did it just to kind of illustrate it further. Again, I'm hitting two different y values at the same x value. But if I come to these two, again, I put my vertical line here, and heck, you can use the vertical line of the y-axis here. I'm only hitting one y value. Again, right here, one y value, one y value, one y value. I know if it gets really steep, it starts to look like, maybe it's going to. But again, if you are not plugging in an x value and getting two different y values, then you probably have a function, right? These are your functions, okay? These are not your functions. And you can do it with the vertical line test, okay? So for these graph mappings now, we're going to go to our second skill. This is going to be domain and range and identifying that. So as I said before, domain is your total set of possible x values. Your range is your possible set of y values. Okay, so let's go through each of these graphs that we just did, and let's see what our domain and range is probably going to be. Okay, so for our first one, this was y equals 2x plus 1. All right. How you could go about solving these and finding domain and range. So for your domain, ask yourself, is there anything, any number that I could not plug into this? Is there anything I could plug into this and like not get a y value in return? Okay. I can't think of anything for this one. I can plug in any number. So this is all real numbers. And in turn, and again, it might be helpful to look at the graph. In turn, I see that my y values are just climbing forever and ever and ever in both directions. They're capturing every single point. So again, the range for this is all real numbers. All right. Let's look at B. So B, again, it looks like it's going left to right for my domain forever and ever and ever in both directions. So just like the first one, this is also all real numbers. And it looks like it's going down and up infinitely as well. So this is also all real numbers. There's nothing that I can't plug into it. Okay. Now let's look at C and D. This is where things might get a little bit wonkier. Okay. If we're looking at C, it looks like it's capturing pretty much everything. It looks like for at least inputs, I can plug any input out. I can plug any input into it, and I can get an output, some kind of output, right? So again, I'm not restricted with my domain on this per se. So again, it's all real numbers. But the range is not the same. And the key to see that is this little part right here. Okay, you see there's a gap. Now, this comes down to, okay, what y value, is it ever going to converge? Is it ever going to get to meeting up together, right? Well, if we look at this graph, let's think about it. If I have something 2 to the x power, all right, I can plug anything into this, right? But that doesn't mean I can get everything back. For example, if I plug 0 in for y, there is not a x value I can plug in to get this to equal each other. I cannot get this to be 0, no matter how hard you try. Even if I took x to the 0 power, anything to the 0 power is just 1. So this might get super close, but it will never touch 0. It'll never touch 0, but it'll get super close. So it's actually greater than 0. Actually, let's find out a different way to write this. If I have my y values, it's always going to be greater than 0. And it's also going to be less than 0. So if I wanted to write that in a more condensed version, I could do it like this. You could do, let's see, something like that. No, I think that's actually how you gotta do it. Yeah, I don't think we can get anything different than that, right? So it has to be greater than 0, and it can also be less than 0, okay? But it'll never equal 0. So that is the range for C, all right? I was trying to see how I can combine it. Couldn't combine it, okay? And then finally for D, we have y equals a plus or minus square root of 25 minus x squared. Okay, if we're looking at this guy, we have a circle, and let's focus on the domain first. Looks like the domain only goes from -5 to 5, so I would have to restrict my domain like this. This is what I was trying to do a little bit earlier, but I couldn't really do it. Can it touch -5 and 5? Absolutely. It absolutely does, so I have to include that in my inequality. Okay? Same thing with the range. It's going from -5 to 5. It's including them, so the range is actually the same as the domain, coincidentally enough. Okay? So when you're going through this, ask yourself for the domain, is there anything I can't plug in? Okay? And if the answer is yes, then restrict your domain accordingly. Okay? So like for D, I have to go from -5 to 5, and that's it. Same thing with the range. Is there anything I can't get? Is there anything that's not possible? So like part C, I had to go and reason, okay, I am never going to get my y to equal 0, so my y can never be 0, but it can be everything else. So y is greater than 0, and it is also less than 0, but it is not 0. Okay? So that's domain and range, and looking at it from a graphical standpoint. Here are some very common symbols that you might run into. Okay, and I'm going to break this down for you pause the video, write them down. Please get them down because you're going to see them here and there, okay? So for your domain, you might see something like X exists within or Y exists within. And usually this little blank is filled with these symbols right here. These symbols represent types of numbers, okay? So for example, this R symbol represents real numbers, okay? Q is rational numbers. So that includes numbers that are that you can put in a fraction form. So you can include it. You can represent as a fraction, is what I'm trying to say. What's an example of something that's not a rational number, like an irrational number?